In this video, we're going to look at some of the basic rules of derivatives. So there are some shortcuts you can use so that you do not have to use the limit definition of a derivative every time you take a derivative. Which, if you had to use that limit definition, derivatives could just be extremely exhausting. But in this case, they're actually pretty quick and easy. So let's look at the first 4 basic rules of derivatives. So the first rule says, if f of x equals c, where c is any real number constant, then the derivative f prime of x is equal to 0. So what that means is the derivative of a constant without a variable multiplied to it, so just a constant all by itself, is 0. So let's look at some examples there. So if f of x equals 4, then the derivative of that would be equal to 0. If f of x equaled e, without a variable on it, but just the number e, then the derivative of e would be 0. All right, I'm not going to do any more examples because the answer of these is always going to be 0. All right, this next rule, rule number 2, is probably one of the biggest rules that you'll go over because we're going to apply it to almost every other thing that we do that applies to derivatives. So this is called the power rule. The power rule, the definition of the power rule says if f of x equals x to the n power, where n is any real number, the derivative f prime of x is equal to n times x to the n minus 1. So what this means is the derivative of a constant, the derivative of x to the n is, first you multiply whatever that n power is in front, and then you subtract 1 from the new power. All right, so let's try a couple examples of that. Okay, so if f of x equals x squared, what you're going to do is to find the derivative. We take this x squared right here, and we bring it out in front. So it would be 2 times x to the 2 minus 1, which gives us then the derivative is equal to 2x to the first power, which would just be 2x. And your number, your power, can be a whole number. So let's try another whole number. So if I have f of x equals x cubed, the derivative then would be, bring the power in front and multiply. So we have 3 times x, and then 3 minus 1 is 2. So there's our derivative. Now the powers can be negative numbers. So if I have f of x equals x to the negative 1 power, then our derivative would be negative 1 times x to the negative 1 minus 1, which means our derivative would be negative x to the negative 2 power. All right, so it's always minus 1 from the power, no matter what kind of number we have. So let's look at one more. So if we have here f of x equals x to the 1/2 power, we want to go then the derivative, which would be multiply that 1/2 in front, x, and then we'll go 1/2 minus 1, which is then the derivative to be, let's see, okay, 1/2 x to the negative 1/2, because 1/2 minus 1 is negative 1/2. So sometimes these end up being a lot more complicated than they started with, and then sometimes they're easier than they started with. Just a general rule of thumb here with derivatives, however your original function started out. So since it started out as, let's say, a negative power, your final answer can be a negative power. If your answer started out with a 1/2 power instead of a square root, you can leave your final answer as a 1/2 power. Okay? Let's go on to the next rule. So rule 3 builds off of the power rule, and it's actually pretty simple, and you probably would have done this anyway if you weren't sure. But what it says is, if a function equals a constant times something, where k is a constant and f and u of x is some function, then the derivative f prime of x is equal to u times the derivative of that function. Alright, so that really just means the derivative of a constant times a function is the constant times the derivative of the function. So let's take a look at a couple examples here. So if I have here f of x equals 7x squared, what you need to do is to find the derivative, you just go 7 times 2x to the first. So that means that the derivative would be 14x. Okay, let's look at one more here, or actually two more. If I have f of x equals 6x cubed, you simply just need to multiply that 3 times the 6, so the derivative would be 18, and then what is 3 minus 1? 3 minus 1 is 2. So there is our final derivative. Alright, let's look at one more. That requires a little bit of more work, but it's still going to be the power rule with the derivative of a constant. So I have 3 over x squared. Now I can't use the power rule if my formula or my function is in this form. So I'm going to transform my function into a format that we can use the power rule. So it would be 3x to the negative 2 power. Alright, so if we go to take the derivative here, we would go negative 2 times 3, which is negative 6, and then negative 2 minus 1 is negative 3. Now remember, the general rule of thumb says if you have a derivative starting out as 3 over something, we need our final answer to be back in that format. So we really just want to make sure we bring our power back down there. And this would be our derivative. So this last rule, it's a little bit harder to write it out. So I'm going to say if we have, or it's the derivative of the sum and difference of multiple functions. So if f of x, it has two functions, either let's call them u of x and v of x. U and x and v of x in calculus is how we represent multiple functions within functions. Alright, so in this case we have two functions either added or subtracted make up one big function. So if we have f of x equals u of x plus or minus v of x, then the derivative is also kind of how you would expect it to be. It would be u prime of x plus or minus v prime of x. So what that says is to take the derivative of a function with multiple parts, separated by addition or subtraction, you just take the derivative of each part. Okay? So let's look at an example. Alright, we've got here f of x equals 6x squared minus 10x plus 5. And if we want to go and take the derivative, it's actually super easy. You have the derivative of this part first, so we're going to go 6 times 2 is 12x to the first. And then the derivative of minus 10x to the first would be minus 10. x to the 0. So then our final answer is, oh, I forgot about the 5. The derivative of a constant is 0, as long as there's no x multiplied on it. Now let's try another one. Let's say I have f of x equals 5x minus the square root of x. So we have that. Now we can't use the power rule in this, and we don't really have a way right now just with square root by itself. So we need to transform the square root of x to a power. So what we end up with is it is really equal to x to the 1/2 power. So we're going to do the derivative of this one right down here. So the derivative of 5x is 5x to the first. We're going to go 1 times 5 is 5. And then subtract 1 from the power. So 1 minus 1 is 0. X to the 0 is 1. So we just have 5. Whenever you have x to the first power, that variable disappears and you're left with whatever the constant is. All right, the second part is minus x to the 1/2. So we're going to go minus 1/2 x to the negative 1/2. All right, now the hardest part of this problem is simplifying. So you want your final answer, since we started with a square root, to end with a square root. Now in order to do that, I better write small. We have f prime of x equals 5 minus. Now a negative power brings the number down like that.